Pesticide resistance public service announcement. Now you may be wondering, what is pesticide resistance? Pesticide resistance is a genetically acquired ability of an organism to survive a pesticide application at doses that once killed most individuals of the same species. When you spray an insect with a pesticide, it kills most of the insects except the two red ones that you see here. The red ones then begin to reproduce and form genetic mutations that make their offspring resistant to the pesticide in the future. Let's take a look at its history. Broad-spectrum pesticides were developed to kill broad ranges of insect pests to promote greater output of agriculture. It also requires a little knowledge of biology or ecology of pest insects. An example of this would be DDT. Before World War II, arsenic was the most widely used broad-spectrum pesticide. It was used in wallpapers, candles, dishes, and dental fillings. After World War II started, DDT was starting to be secretly used. DDT was used for spraying barracks and bedding for bugs, dusting soldiers and civilians for body lice, near military bases for mosquitoes. In the 1940s, many people saw many economical benefits by using DDT as a pesticide. It was broad-spectrum, effective, persistent, and very cheap. After World War II, DDT was made available to the public. DDT was being used for control of household pests. By the mid-1940s, concern developed regarding the environmental impact of DDT use. Evidence emerged that proved DDT to be a persistent organic pollutant. It is absorbed by soil and has a half-life of up to 30 years. Residues of DDT were found worldwide and eventually banned in 1972 due to health concerns and danger to other wildlife. In 1947, housefly resistance to DDT was documented. Insects which survived the toxins in DDT survived to breed and pass on whatever small amount of resistance they had naturally to the DDT. As more generations passed with only the survivors breeding, their resistance increased and fewer surrendered to the toxins. Conventional insecticides made up about 81% of the total resistant cases. Pesticide resistance happens when a population of pests have genetic variability, which increases their chances to have more genetic mutations that can introduce new traits that aren't affected by pesticide resistance and be passed down to create new generations that are also pesticide resistant. Pesticide resistance keeps occurring due to the pesticide treadmill. The pesticide treadmill is a situation in which it becomes necessary for a farmer to continue using pesticides regularly because they have become an indispensable part of their agricultural cycle. Insecticide resistance is increasing in occurrence. Farmers in the USA lost 7% of their crops due to insects in the 1940s. Over the 1980s and 1990s, the loss was 13%, even though more insecticides were being used. Alternatives to pesticides include GMOs, biological control, and integrated pest management. Biological control is the use of living organisms to reduce a pest population and reduces the use of pesticides.